It's okay. We finished, guy. Probably I will explain the code. Okay, let's go. I will try explain my resolutions. There are 43 minutes left. Okay, for the first question, uh, we need to find the longest substring. Substring means continuing sequence. Okay. For to solve the problem, you need I need to check the constraints. Using the constraint only 100. The problem the, with the constraint, I can solve the problem use uh, uh, one cubic algorithm. For example, for each subsequence, I check if this subsequence is nice. If it's nice, check if is the longest that I find and return the longest. Okay. In the second question, here, I got very confused and make many errors in this problem, but in the problem you need to find arrays to match. You need to match these groups inside these nums in the same order. In the same order, these groups, you need to match those groups inside this. Okay, to solve this, you need to use an algorithm similar to string match. You need to try match the first as soon as possible. When you match this, for example here, you need to try and match the another sequence in the remaining array. Using the constraints and equal to 10.3, we can solve the problem using a quadratic algorithm. For each position, search the element. If I find, search the next. If I don't find, reset the search. This is a N2 algorithm, but because the program have a small constraint, this algorithm is good. But if the program have one bigger constraint, we need to solve using some string match algorithm. For example, z function or something like this, or key MP. In the 30 problem, map of heights peak, for me is the easiest problem. It's pretty simple. You have a matrix of is water with 0 is land and 1 is water. The program requires you one map, one matrix with height of each cell. The water must be 0, and the land, you have to maximize the height of the land. And if land must be at most 1 in height from the to the adjacent cells. For example, in this case, the 1 have only 1 to the right of difference and only 1 to the bottom of difference. It's a very simple program. It's an application of a BFS search of a graph. You only start a BFS with start in the water position, setting the height to 0, and try move to the adjacent vets or cells, increasing the height and return. For example, in this example, I have 0, 0. The adjacent of the 0 is all 1, and adjacent of 1 that is not 0 or 1 is 2. It's very simple, as easiest program for me. And the last program, you have one tree, and the tree, each node of the tree have one number, and you need to find the closest ancestor. In otherwise, the closest node above one node that have a coprime value. For the program, checking the constraints, I see that the program have a very small range of the numbers that nodes can be. Using these constraints, I only check for each node, check the 50 values, possible values, the closest vets above that have one of these values and is coprime for the current value of the vets. For example, for do this, I make this code. I have one vector or vector of pairs for vector and height, one graph, and my answer. Make the graph and make a DFS. For each DFS, check all values that have at least one vets, and the value is coprime to the current vets. If is correct, if is true, check if is the closest as possible. If is the closest as possible, the answer will be the closest that I find here, and I need to push the current vertices V and 8. 8 is the height of the node. For example, I start 0 here, 1 under, 2, and so. After that, only DFS the children's, and when you retrieve back the DFS, you need to pop back. Okay, guys. If you notice some English errors, please comment below. If you like this video, please give me a thumbs up. And see you next time, guys. Peace. Stop recording and bye.